This is the last lesson on dividing radicals, and it's the last lesson on the operations with radicals unit in Pre-Cal 11. So we're going to go to page 81, but there's actually, oh no, I'm going to do this first. It says here, so when we were looking at dividing radicals, and we had to rationalize the denominator, and so we would multiply it by the similar radical. When we have a binomial in the denominator, like we have here, a binomial is something with two terms, we multiply the numerator and the denominator by the conjugate of the binomial denominator. And so I'll just remind you that the conjugate is, that means that you change the plus or the minus, you change the sign between the two terms. And that makes it a difference of squares. All right, and we'll see some we'll see a bunch of examples of that because that's what this whole lesson is on. There is not enough space here to do these three examples to do them justice. So we're going to do them on a separate page. Well, I'm going to do them on a separate page, and I really recommend that you do them on a separate page just because these are your examples and they're really, it's worth having them written out really clearly. Okay, so here's our first one, simplify by rationalizing the denominator. So what I'm going to do here is I'm going to multiply that whole fraction by another fraction, and I'm driven by what's in the denominator, and I'm just going to change that minus to a plus. So this is going to be root 5 plus root 3, and that means I'm going to multiply it by root 5 plus root 3 on the top. Now, it's really important that you understand what we're actually doing here is I'm multiplying it by 1, because anything divided by itself is 1. So if I multiply it by 1, I'm not changing how much it is, I'm just changing what it looks like, okay? And then I can do the numerator here. I can do that part on the fly. So that's going to be, well, I'll just rewrite it. That's going to equal 2 times the square root of 5 plus the square root of 3. And it's probably not worth actually distributing that at this point because we are going to want to cancel out anything that we can. So let's just leave that for now. And then the bottom part, well, don't get caught in taking too many shortcuts with this. I'm actually, what I'm going to do here is I'm going to grab this piece of it, and I'm going to come over to the side, and I'm going to do the square root of 5 minus the square root of 3 times the square root of 5 plus the square root of 3. Because I need to actually FOIL this, don't I? I need to go first times first, outer times outer, inner times inner, and last times last. So let's do that. I've got root 5 times root 5, okay? And then plus root 5 times root 3, and then minus root 5 times root 3, and then minus root 3 times root 3. And then if I simplify that, I can see that, well, I have root 5 times root 5 is just 5. And then this part, I've got plus 5 root 3 minus 5 root 3. So that actually cancels out. And then I have minus root 3 times root 3, which is just 3. So this actually equals 5 minus 3, which equals 2. So then I'm going to take this 2 piece and I'm going to put that back in the denominator over here. Okay, now what I did by writing that off at the side is I didn't have to write out the denominator this many times in order, or sorry, I didn't need to write out the numerator this many times in order to simplify the denominator, because most of us don't bother doing that, and then you lose the denominator. You forget that you had it there. So by taking just a piece of this off to the side, anything I do off to the side, I know I'm not finished. I know that that's just a piece of what I actually have going on back on the left side. So I'm going to take it back over and put it back into the whole thing, and then I can look at the whole thing again. And now when I look at this, I can see that I can cancel these 2's, and my answer is just the square root of 5 plus the square root of 3. And that's my answer for number 1. Okay. For example B, I'm again going to multiply by the conjugate because I've got a binomial in the denominator. So I'm going to multiply this by the square root of 6 minus the square root. Oh, sorry, it's not the square root, it's just minus 2. And then on top of that is the same thing, root 6 minus 2. And you'll notice that I do tend to write the denominator first here because that is what's driving it, right? I'm looking at the denominator, I'm multiplying this by the conjugate, or multiplying that by the conjugate, and then I'm just doing the same thing up top, okay? And then this top part, that looks kind of scary to multiply. So I'm going to bring that over to the side, and I've got root 6 minus 2 times root 6 minus 2. And again, I have to FOIL this, so I've got root 6 times root 6, which is root 36. So I'm going to write this a little bit different this time because there's a couple of different ways you can do that. You just have to do one that makes sense to you, okay? But please be cautious that you're not, like, if you notice these are the same thing, you have to FOIL it. You can't like square the first bit and square the second bit. That doesn't work, okay? Anyway, I now have 6 times negative root 2. That's negative 2 root 6. And then I have another negative 2 root 6. And then I have negative 2 times, or sorry, yeah, negative 2 times negative 2 is plus 4. These do not cancel out this time. Be really careful about that. So this is going to be 6 minus 4 root 6 plus 4, which is going to be 10 minus 4 root 6. So I'm going to put that back over here, and that's what's in my numerator, which is 10 minus 4 root 6. Now my denominator, I actually, because this is a difference of squares, I'm going to shortcut it this time, okay? So I'm going to have root 6 times root 6, which is 6, and then minus 2 times 2, which is 4. Now, if you notice up here, I did the whole long thing, but my denominator, if I had shortcut the denominator here, I would have root 5 times root 5 is 5, minus root 3 times root 3 is 2. So it was 5 minus, sorry, root 3 times root 3 is 3. So it's 5 minus 3, which equals 2. So eventually you're going to be able to shortcut the denominator because the reason we're picking the conjugate to multiply it by is so that that simplification happens and those middle terms with the radicals in them disappear. Therefore, our denominator is now rational. It's not the square root of some random number. All right, so now I can simplify this. I've got, I've got 10 minus 4 root 6 over 2. Now, I can simplify this further, and I need to, but be really cautious that the way you have to do this, whether you show this or not, but you have to take the 2 out of both of them. Okay, so one way of looking at this is I've got 10 over 2 minus 4 root 6 over 2, which equals 5 minus 2 root 6. Okay, so that's one way that you can do it. The other way you can do it is factor out. I've got a 2 in the denominator. I see that I can factor a 2 out of the numerator, so I can make this 2 times 5 minus 2 root 6 all over 2. And then those 2's cancel, which gets me the 5 minus 2 root 6. The mistake I see most often is that people reduce this 2 with the 10 or the 4, but not both, and that's incorrect. You have to get both of them, okay, whichever technique you use. All right, next example. This is actually the simplest of the three. I'm not sure why it's the third example, but I've got a binomial in the denominator, so I'm going to multiply by the conjugate, which is 1 plus root x, and that's 1 plus root x on the numerator. So my numerator is 1 times something, which is just the something. It's 1 plus root x. And in the denominator, I've got 1 times 1, which is 1, minus, it's always minus, remember, because this is a difference of squares. And then root x times root x is just x. That's my answer. I can't simplify that any further. There we go. That's it. All right, let's go back to the page in your workbook, and there we can do the rest of them fit on the page. And there's just these. There's 2 more examples, and then we're done. Okay, express blah with a whole number in the denominator. That means rationalize it. And you are always expected to rationalize your denominator unless you're specifically told not to. It's one of those assumptions that you're just always supposed to do it. You're always supposed to reduce your fractions. You're always supposed to simplify and rationalize the denominator. All right, I'm going to rewrite this because there's not enough space here. So this is square root of 8 minus root 3 over 4 root 3, 4 root 3 minus 2. And then that's times, or root 2, sorry, minus root 2. Let me just clean that up a bit. 4 root 3. Okay, so I'm going to multiply that by 4 root 3 minus 2 over, or under 4 root 3, plus 2, plus 2. Oops. All right. That the numerator is a nightmare, so I'm going to come over to the side and I'm going to see if I can simplify things here. So this is going to be root 8 minus root 3 in brackets times 4 root 3, no, plus root 2. Sorry, I am falling asleep on the job here. Plus root 2. Okay. Be really cautious that you're remembering, although I'm not writing it this way, it is this term times this term. So when I'm multiplying it, it's this piece times this. It's not just there's a times in the middle. It's this whole thing in brackets times this whole thing in brackets. I didn't, strictly speaking, need the brackets here because there's this dot between them, between the whole fractions. But when I write it over here, I absolutely have to put that in brackets. Please just be really, really careful about that. All right, so I'm going to expand this. So I've got, this is going to be 4 times root 8 root 3, so that's going to be 4 times root 24. And then 8 times 2, that's going to be plus root 16, and then it's going to be minus 4 root 9, and then minus 2 times 3, it's root 6. Let's simplify this. So 24, that is 4 times 6, so that's 2 root 6, and then if I multiply that by 8, that is going to be 2 times 4 is 8 root 6. And then root 16 is just 4, and well, root 9 is just 3, so that's minus 12, and then minus root 6. So if I group things, I get 8 root 6 minus root 6 is 7 root 6. 4 minus 12 is minus 8. So that's my simplified numerator. So I can draw some arrows here that this went over here, and then this is coming back here. So my numerator is now 7 root 6 minus 8. And my denominator, I'm just going to do this on the fly. It's going to be 4 times 4 times 3. So that's 16 times 3. Or I might write that as 16 times root 9, just to remember that, make sure that I'm not squaring the wrong thing or whatever. It's the 4 times the 4, but then it's just 1 3. It's not 3 times 3. It's just root 3 times root 3, which is 3 or root 9. And then it's minus, and then root 2 times root 2 is root 4. And then if I simplify that, that's 7 root 6 minus 8 over 16 times 3 is 48, and root 4 is, of course, 2. So that is 7 root 6 minus 8 over 46. And I do want to check that and see if I can factor anything out of the top that lets me reduce that. But since 7 is a prime number, no, there's not. And there's my answer. Right? One more example. The area of a trapezoid is given by the formula. So a trapezoid is a shape that has 2 parallel sides, and then the other 2 sides are not necessarily, like the up and downs, are not necessarily equal. And it's given by the formula 1/2 h times a plus b, where a and b are the lengths of the parallel sides. So this is a and this is b, and h is just the distance between them, the height. So if the area of a trapezoid is 20 centimeters and parallel sides are root 6 and root 5, find the exact value of the distance, which is the height. So I'm going to write out the formula and then plug in what I know. So I've got area equals 1/2 h times a plus b. Now, I solved this myself by putting the numbers in, but you could also just manipulate the equation to solve for h. Maybe I'll do that down here. So if I've got a equals 1/2 h times a plus b, I'm going to multiply this side by 2 and this side by 2, and then those 2's cancel out, and I have 2a equals h times a plus b, and then I'm going to divide this side by a plus b, and I'm going to divide this side by a plus b. The a plus b's cancel out, and I end up with h equals 2a over, or 2 capital A, sorry. That's important. 2 times capital A over a plus b. I don't always remember to, and then when I have this formula, I can just plug in my a and my capital A and my a plus b. I just didn't think about that, so we're going to do it the other way. So I'm back up to this one. I know that my area is 20, and that equals 1/2 times h times a plus b. So a and b, it doesn't matter which one's which, so I'll just put them in the order they are given to us, root 6 plus root 5. And now I need to solve that. And I'm going to do the same thing. I'm going to multiply this side by 2 to get rid of that fraction, and I'm going to multiply this side by 2. So I have 40 equals h times root 6 plus root 5. And then I need to divide both sides by root 6 plus root 5. Divide that side by root 6 plus root 5, and those cancel out. And what I have now is h equals 40 over root 6 plus root 5. And I need to rationalize that denominator, so I'm going to multiply this by root 6 minus root 5 and root 6 minus root 5 in the numerator. So when I expand that, I get my height is 40 times root 6 minus root 5 divided by root 6 times root 6 is 6, and root 5 minus root 5 is 5. So that's just 1. So my height equals 4 times root 6 minus root 5 centimeters. And that's the exact value. Remember, they're asking, when they ask for the exact value, they're looking for it in radical form, okay, not simplified, not done on the calculator to get an approximate number. Now, you totally can do that to check your answer, and you are totally encouraged to do that. You should be checking every answer you possibly can. Okay, and that's it for the lesson. All right, see you in class.